So again, who is this for? This workflow is for utilities doing that D over D capacity analysis, looking at I&I, looking at master planning and growth, particularly on sewer networks here. It's for engineers, and again, we've talked with folks in the last couple of months that are looking for something a little bit more accurate and effective than simply having a spreadsheet and a Manning's-derived equation that I'll actually compare in this 20 minutes here to InfoWorks ICM. And then again, it's for anyone that in the past has experience with any of those solutions there and wants to see how that can be done in InfoWorks ICM maybe more effectively and accurately there. So everything we'll be talking through today is with it in InfoWorks ICM, the standard edition, not the ultimate edition, the basic edition of InfoWorks ICM. And we're going to go through this very quick kind of 4-step workflow here. So it is a pretty quick process, again, to do this analysis in InfoWorks ICM. The first step we'll look at is importing from GIS or whatever source data you have. And we're really only concerned about 3 items if we're doing basic sanitary analysis here. We're concerned with our pipes or our conduits, as they're called within InfoWorks ICM. We're concerned with our manholes, our links between those pipes, whatever that node information is. In this model we'll see here, we'll be looking at manholes and outfalls. That's it. But of course, if you had pumps and other items, you can certainly include those as well. And then last thing we'll look at is particular to dry weather flow is parcel information, right? So we'll import just those 3 elements into InfoWorks ICM and derive our dry weather flow based off of those. Next step, and this is a big thing for folks that maybe are just doing this capacity analysis based on steady state analysis, if you will. We're going to create diagonal curves within InfoWorks ICM to more accurately look at the flows over the course of a day for our dry weather flow there. So this is going to be a key component to make sure we're not, undersizing or oversizing our elements there, and we're taking into account the different changes over the course of the day. And then in the third step, we're going to link basically those dry weather flow curves that you create within InfoWorks ICM to the parcel information that we imported from GIS. So within that parcel information, you likely will have land use IDs. That's what we'll be looking at in this case. And we'll be linking those curves then to the different land use IDs from those parcels. And then actually after step 3, you don't even have to run any actual ICM analysis to begin to compare maybe to a steady state kind of capacity analysis that you might have been doing, but we will do some comparison and then look at some of the outputs from InfoWorks ICM as well there in the last step. So I'm going to go to the next slide, and I'm going to go live here to InfoWorks ICM, nothing pre-recorded. But I'll dive right into the software here. So this is InfoWorks ICM, and we're going to work through those same 4 steps outlined in the PowerPoint there. So first things first, when you're importing the sanitary sewer analysis into InfoWorks ICM, you want to identify those 3, again, layers that we want to be importing. So first thing, pipes we've got in here, nodes, and then parcels, which we imported. In this case, you want to import into InfoWorks ICM as subcatchments. ICM doesn't have a parcels layer because InfoWorks ICM does include, again, stormwater analysis, all different types of analysis as well. So you want to import that parcels as subcatchments into InfoWorks ICM so that can actually be used for a number of different things in the future if you want. And a couple more notes here. Again, nodes can include different types of elements in here. Mostly I've got manholes, and then I've got outfalls here where all the water's exiting. But it can include a number of different elements that you could combine from different shapefiles or feature classes all into the nodes layer in InfoWorks ICM. Other thing I wanted to point out here, parcels, again, imported as subcatchments. And if you do have address points or you're creating your dry weather flow from, again, that point data, you can convert that to subcatchments, and there are other ways of doing that as necessary here. So if you come in here, you can see we've got, we can take address point information and add that to the populations of our subcatchments, or we can create kind of boundaries around those address points if that's where you're kind of aggregating all your diurnal flows from. That works as well. It doesn't have to be polygon information that you're importing here. And then last thing, again, pipes we see here. This should include, again, laterals, trunk lines, gravity, or force mains. And one of the other nice things about InfoWorks ICM is because it's such a robust simulation engine, if you've got force mains and lift stations in here, it's going to model that much more accurately than other solutions in many cases here. So whatever types of conduits you have in here, do import those in. And the way to do that is to come up here to Network, Import, Open Data Import Center. And here's where you do kind of the field mapping to import to the nodes, the conduits, and the sub-catchment layers here that InfoWorks ICM comes prepackaged with and has the field that you want to be populating here. Again, I'm not going to go into all the details here so we can get through this in 20 minutes, but there are a number of different data source types that you can import from to get into InfoWorks ICM, including GIS, Excel, enterprise level databases. You can keep this up to date in a variety of ways with scripts or by merging and overriding different fields as things change. A lot of different ways to clean and edit this data, even the ones it's within InfoWorks ICM, right? If you might not have all the information automatically within your GIS for your pipes or your manholes, et cetera, but there are a lot of tools within InfoWorks ICM to clean this and make this a very manageable process here. I don't know, Ryan, if there's anything you wanted to add in terms of what you've seen.
Add real quick, because I know a lot of people like to use their GIS data kind of as the record of the ultimate record of what they have or whatever. And so as things get updated in the GIS or geodatabase or whatever, we do have those options of loading and saving configuration, so you're not having to remap this stuff all the time if you have some updates to your GIS.
Yeah, perfect. And there's different ways too once you get into InfoWorks ICM. If you don't have, the roughness coefficient, right, you can assume that from the material value of your conduit.
Yeah, that's another good point. There are user text and user number fields.
Yeah, perfect. All right, so assuming we can do that, we get to this point where we've got the, again, there's those three elements cleaned up and included into InfoWorks ICM. Again, lots of tools in here for tracing and making sure everything's connected nicely for your hydraulic network. But assuming we've got that step one done, everything's snapped together, works generally well, fields populated. The next step and thing to do here would be to create again, a wastewater profile. And then this is the example I've built in this model here. So in this case, these wastewater profiles are actually designed off of some data from a particular utility we've worked with somewhat recently. So you can see in this table here, they were basically calculating dry weather flows based off of the area of different land use types. So you might be doing something similar out there where you've got these different land use types and you can designate what's the average flow based on the area of that parcel data that you're building from there. So inside of InfoWorks ICM, you can see I've got my wastewater profile object that has multiple curves that match up to some of those types in there. So this model is all residential. So I've got my 4 different residential curves and then my 1 commercial curve in here as well. And the way InfoWorks ICM works is that the InfoWorks ICM engine, at least, everything is based off of a per capita flow instead of per area. But you can easily convert this per capita flow to per area by basically assigning the population of these different subcatchments. And here I'll close this one out and open this workspace here to show this. You can easily assign that population based off of the area of your different parcels here. So that's what I've done in this case. So the flows themselves still come from and are based off of the area, but we're just basically crossing out the denominator, if you will, kind of cross multiplying it. I almost thought of it as we're basically making that population almost a moot point and equal to the area here. The other thing you can do within these, the wastewater profile is, again, assign the actual curves over a 24-hour period. for each of these different types of flows here. So you can see I've got commercial and residential curves, and these have different factors placed on them depending on the time of day. So peak flows coming around, 9 a.m. for residential, commercial, more stable throughout the day, if you will, and everything drops off here at night. So this is a crucial part and a way to really improve on some steady state analysis. We can add those factors to our average flow, which we specify here. Right? And there's lots of other things you could add into your wastewater profile. But again, if you're just doing capacity analysis, these are really the only items you have to worry about here. Okay. Next.
And I was just going to add on to that. You might notice a bunch of grayed out things in there. So really that just means that it's been used in a run before. So the way to get around that would just be to copy and paste that object back into there. That being said, there's also the population component that typically gets used within InfoWorks ICM, and that's typically what's kind of like tweaked as far as calibrating the model and things like that. We also have swim networks in InfoWorks ICM. That was added a couple of years ago to be able to, so if you are coming from one of those other swim-based products or just familiar with swim-based products in general, using the swim networks within InfoWorks ICM should look very familiar in terms of the workflows and things.
Yeah, perfect. Almost forgot about that swim network there, Ryan. But yeah, once you have those, no, that's perfect.
Flow.
No. So once those wastewater profiles are created here, we kind of move on to step 3. We have our wastewater curves, we have our GIS data. Next, we need to connect some of our parcel information specifically to our profiles that we just created in here. So if we look back at our profiles, we see that these are also numbered. 1 is R1, 2 is R2, 3 is R3. So we come here, we can see on this map, I've done this already, where I've joined basically that land use that we imported from GIS to the wastewater profile we created. 5 for commercial, R3, 3, R2, 2. And I did this and created the population data with a couple very quick SQL queries here. So this first one here sets the wastewater profile and calculates the population size. You can do 2 things in one SQL query, actually. So very easy, set wastewater profile for my subcatchments where land use equals 1. And then same thing for all of those. And that could go on for as many land use types as you have. And then again, very simple way of kind of crossing out the denominator there, making this per area, not per population. Just set the total population equal to the total area for those different what we're calling parcels, but InfoWorks ICM calls subcatchments here. So very simple process there to populate everything here. And then the next thing to do, the next quick SQL query was I assigned the dry weather flow from each of the subcatchments to the closest node. So all of these parcels here are going to go to this node, all the parcels here to this node, and that was done through another SQL query. These can be used spatially as well. We're saying set that node ID for the subcatchment to if it's a manhole to the closest one if it's within 5,000 feet. So just the closest one there. So an easy way of kind of allocating those loads to the closest nodes throughout my network here.
Yeah, and I think that answers the one question we've got that came in of assigning stuff. So let us know if it didn't.
Perfect. Yeah, so with that, we've actually done everything for a simple kind of steady state analysis, which is awesome. We can start to compare actually peak flows to what we might have previously doing with a spreadsheet and Manning's equation without even doing any analysis, without any runs in InfoWorks ICM, just with that kind of data editing. So we see, if I go back to the PowerPoint here, we see this is again what a utility we talked to recently was doing, and we showed you could do this within InfoWorks ICM. So this Cutter's formula is basically a derivative of the Manning's equation, right? And you can use these inputs to generate these outputs. And in this case, they're using this to generate kind of what the max flow would be, max capacity of a particular pipe. And these translate very well into InfoWorks ICM without even running an analysis. So you see here at the bottom, These inputs are the same inputs and data that InfoWorks ICM is using. And again, before we even do an analysis, we're calculating the full capacity of that particular conduit, but we're using the full St. Venant equations ICM sim engine to calculate that full capacity, and not just the Manning's formula, if you will, here. So if I go back to the model here, again, I haven't run an analysis on this network. It's just the network itself. And we can see that, again, a particular pipe I'm looking at here, got the diameter, I've got the Manning's roughness, length of pipe, gradient, and then here is the full capacity. And that's great. You might say that we can do that in InfoWorks ICM, but what if I want to compare that to what I was doing before? Again, we can create SQL queries that build in that equation into InfoWorks ICM, populate that data in user number fields, and then actually start to compare that to that full capacity calculated by InfoWorks ICM. So you see in this quick SQL query and table I've got here, the pipe IDs, those inputs, and then how they kind of compare to, again, that Cutter's formula calculation and then the InfoWorks ICM calculation. So you see what's interesting in this model is that across the board, the InfoWorks ICM calculated capacity is a little bit more than the Cutter's formula max capacity for every pipe reach here. So again, you're getting that extra amount of detail that allows you to maybe better size those pipes in a new development or for master planning for D over D analysis when you're doing that ICM calculation there. Okay, but if we, again, do want to go maybe a step further here and start to show, actual extended time series simulation results here. That's certainly the next step you can easily do within InfoWorks ICM as well. So in this model, very simply, just use that wastewater profile and the network itself to run a very simple dry weather flow simulation. And in here, you can start to easily also create different scenarios. So here I've got my base scenario, which we can see here it was pretty boring. No SSO events, which is good. I guess you want boring, but I want to make it more exciting. We have an actual comparison. I multiplied that scenario in the dry weather flows by multiplying the population from each of those parcels by 2, 5, 100, 25. And I did this over these runs are over 3-day periods here on a particular day. And I really didn't have to specify anything for these time steps. So again, the way these runs are generated is just simply by dragging and dropping those elements in here. And again, there are lots of other things you can do within InfoWorks ICM, and maybe you'd have to do these things in the future, right? As your utility does more than just capacity analysis. But if you just want to do this with InfoWorks ICM, you can certainly do that. And these are the only boxes you really need to worry about here. So ran these analyses. You can see some of the results here. You can see I was able to color code the map, look at things like the freeboard on each of the manholes. You can see in here, I'm looking at the max results here. So you can see, and if I multiply the dry weather flow by 100, that we're getting flooding or getting overflows in this scenario here. Again, you can open up a lot of different ways to visualize some of these results here. Here I've got a map with some of those similar graphics on my times 25 dry weather flow, and I've got the map labeled here and zoomed in, and I can create these different displays and run my simulation as well to look at different periods over a particular analysis here. So once this loads up here, I can start to play this. You can see the numbers change dynamically here on the screen. If I want to, jump ahead, I can quickly do that using the option up here in the top left. And if I want to look at the max results, I can switch to that pretty easily as well. So I think that's it in terms of, I know that is it, in terms of doing that basic sanitary sewer analysis in InfoWorks ICM. Hopefully that gives folks out there that extra bit of confidence to do some of this in a program that can do a little bit more than what you're previously used to. And yeah, hope that was helpful.